Hey everyone, welcome back to lesson 6, I believe, day 6, whatever. um, Today we're going to be doing part of the work to do the inverse of matrices. We're actually just going to find the cofactor matrix, and we're going to take it from there. Uh, I'm going to showcase some of my rabbit hole here as I have been, and at this point in time, we're going to I'm really contemplating just switching to maybe a live stream method where I live stream me myself learning it, and then filming these videos later. Because honestly, that'd be better for following that stream of consciousness, stream of thought, kind of thinking and logic and all that. But the thing is that I'm concerned about is like I don't have a great space where I can just sit and live stream for several hours on end. Even right now, maybe you can hear some background noise. So um, that might be the case. So I'm gonna try to showcase some of my rabbit hole here. It was actually quite interesting for me to see the properties of a cofactor matrix. Let's just go through some of these tabs before I start moving on. So I just looked up the inverse of matrix, got this link to a website by Byju's, which is actually a popular, or used to be a popular website in India. I didn't get much out of this in terms of how do I actually progress, but I saw this about the adjoint method, which I had mentioned in my previous episode, but I actually wasn't 100% sure what the methods were. I didn't remember. Uh, so I looked up the adjunct of a matrix, and it's essentially just the transpose of the cofactor matrix, right? Which is at which point I looked up cofactor matrix, but actually before that I looked up the differentiators between singular and non-singular matrices. Not 100% sure why at this point in time, but I did. Oh, Q math. There's some issue. Oh, okay, now we're back up. So this was the website that really cemented, cofactor matrices, how they're calculated. There's how you can use them for the determinant, the adjoint, the inverse of the matrix. That was like super helpful, super nice actually as well, because I actually didn't know some of this stuff. This was, what is this? Oh, matrix inversion methods. I just wanted to see because I felt like I was getting a couple of different things. And another thing I didn't notice is not provided here is that uh, the especially if you're going down the second method, this algorithmic way doesn't actually solve the determinant of a 2 by 2 matrix. Sorry, not determinant, the cofactor matrix of a 2 by 2 matrix. That's kind of similar to determinants, where it's really defined for 2 by 2 matrices, and then everything is like uh, derived from like this repetitive algorithm. Um, I don't know if that's actually true, but that's what I made sense of it. Um, and yeah, at this point, at somewhere over here, I read about standard basis vectors, and I looked those up as well because it was interesting to me. I definitely didn't go the Gauss-Jordan elimination way, even though that makes a lot of sense. Just because once again, we're doing Gaussian elimination soon, and I'd have to write the code for like your elementary row operations and all that. Anyway, so I figured like maybe I could come back to it then and do the Gauss-Jordan elimination then, something like that. I'm not really sure. I looked up standard basis vectors because I think it was mentioned somewhere over here. Um, somewhere, happened somewhere. I don't remember where. Um, this is the bug that I ran into that I think I mentioned in the previous episode regarding how what is the operator precedence for unary operators in in Python, and exponentiation actually has a higher operator. So I had like a bug that was super annoying. So some of the generated code gave me some NumPy stuff as well that I just ended up looking up. NumPy all closed. That was, let me see if I can find that generated code. No, not matrix inversion methods. Maybe it is here. No, it's not here. Determinant of a matrix, nope. Matrix operations tests, maybe it was this. Yeah, so when I was first creating the inverse, like the tests, because the actual task, in case you guys don't remember, wasn't actually to do the inverse from hand. It was just to test it using NumPy linalg. But I just kind of went ahead and did it anyways, just to like learn a little bit more, you know, and challenge myself a little bit. So I was looking up the functions here, like np-array equals. Some of these are obvious, like np-array equals, like element-wise, are they equal? That makes complete sense. NP linalg det, that's just getting the determinant. Linalg inver, which is the inverse, all close. All close, I believe. Let me see if I have that here somewhere. I have it here somewhere. Yeah, here. If element wise, it's pretty damn close, you know, just to deal with floating point issues and things like that. Where is the? Yeah. That's all close. It's fairly sure. This at operator is the matrix multiplication operator. We've talked about that. I gives you the identity matrix. This, I didn't know that the condition number being this high is what kind of showcases whether something is invertible or not. So I did not know that. I'm still not 100% sure what condition numbers are. It's somewhere here in this mess of tabs that I'll look it up. I think it's over here somewhere. Yeah, what is the condition number? It's basically the norms of the matrix and its inverse, etc., etc. So yeah, I just kind of went down this rabbit hole, looking all these things up, understanding these things. It was super interesting. I highly recommend you do the same. I really do want to do these live stream things because I feel like just showing you like, oh, I thought about this and I googled that and etc., etc. It's not doing the best job of showcasing what I mean about, like, you know, just spending time thinking about things and being curious and asking those questions, right? Because it starts with curiosity, wanting to ask those questions and then following through to understand those questions and then ruminating on that and trying to understand what is going on. You know, and once again, at some point you'll hit bedrock in terms of this, and that's when you snap back to like, okay, I'm just going to do this, right? And every time you get close to that bedrock, you'll start chipping away at it, and eventually it'll break through. That's how I've gotten to where I'm at so far, and it takes, it's like death by 1,000 cuts. It takes like repeatedly coming back to the same place again and again, and then at some point, like, you'll have learned enough other things where it's like, oh, and then everything breaks open, right? So never give up. That's another thing. Just don't give up, you know. Anyways, we're gonna get into the code. We're just gonna do the cofactor matrix, honestly. Or you know what? We'll start the work for. We'll just call def inverse. Inverse mat, right? We have to check if it's invertible, for which we need to get the determinants. So if det colon, I'm going to use the walrus operator again, determinant mat equals 0, aka it's singular. We'll raise, I keep raising value errors. I actually don't know if that's the most appropriate. Let's see if there's, I guess we could do an arithmetic error, but I'm not sure if that would be considered appropriate. I don't know. I'll look that up at some other point, but it's a value error. If it's a singular matrix, I'll just say matrix is singular, non-invertible, right? That's an easy check. Okay. And with the determinant in hand, we want to get the cofactor matrix. So cofactor matrix equals, okay, so to get the cofactor matrix, let's call this def cofactor mat, right? What you're gonna want to do, what is the actual cofactor matrix? It's essentially, I'm just gonna pull this up from here, but it's essentially for each element in every row and column, you take that element. You get the determinant of the minor relative to that element, and you multiply that with -1 raised to the power of I plus j. So in the top left at 1, 1, it'll be I plus j is 1 plus 1. So -1 raised to the power of 2, which is 1. And then it's negative, and then it's positive. It just keeps swapping from there for the first row. And then from the next row, it's 1, 2. So it starts at 3. So it starts at negative and then swaps. It's like that. Similar to how we calculate the determinant over here, except here we don't. In the cofactor matrix, we just do that, and that is the cofactor matrix. We don't actually multiply it with the element itself, which is what you have to do for the determinant, or at least do that for one row or one column to get the determinant, or one of the ways to get the determinant, as I'm learning. There are several pathways to that solution. So anyways, I don't know how to spell cofactor, so I'm just going to respell that. So to get the cofactor matrix, we need to get I got a little notification. Oh, my buddy's playing video games and he's trying to invite me, and I'm a bit busy with you guys. So I'm not going to do that right now. But let me think about this. So I have a matrix, right? I want to create a new matrix. I'm going to try and do this in one line because I remember being able to do it in one line. So let's see if I can just redo this purely from memory. And then I actually didn't test this code on its own. I just tested it in the context of doing the inverses, and my asserts for the inverse matrix worked fine. So we're just gonna have to generate a few answers from GPT and see if we're right, or just look up some popular ones. I'm too lazy to look up popular ones. So, oh my boys. Okay, so apparently my boys be watching this video. They're messaging me right now. Anyways, getting back to this, they just it's funny. They're like saying I'm a big YouTube star now, so that's why I don't want to play with them anymore. Yeah, I don't. That's me laughing to basically no one, because as of right now, I don't think anyone has viewed these videos. They just know because I think they're subscribed to my channel from a long time ago. Anyways, back to this. So what is it? We want to do -1 raised to the power of I plus j. We're going to do +2 because these numbers start from 0. And we're also going to wrap the -1 so we don't have the issue with the precedence of order. We're going to wrap this whole thing actually just to be on the safe side, right? For j in range len mat 0, right? And go for I in range len mat. Okay, that's part of the solution. There's still more to this here. What is more? Times, what are we doing here? It's -1 raised to the power of I plus j plus 2. It's getting the determinant, so we need to get the determinant of the minor. So determinant, and we already wrote in the last video the get minor function over here. I'm just going to reuse that, right? And we already wrote it in a generic way, so boom, bam, we're already done, right? We just put I, j, and mat, right? Boom. Okay. If I remember accurately, that is already quite right. We're just going to generate a new chat. Generate some asserts. I call them some tests. Python to check my code for getting the cofactor matrix, pure Python, no NumPy. Think that should give us some decent tests. I'm using 04 mini high here, so hopefully we won't have to double check these asserts. Okay, it's spending some time thinking. I'm just gonna hit copy on this. Oh, what's this code it gives me? Assumes def cofactor me. Oh, it's just, and then it's in the scope. Okay, so it's actually just being really good about doing the type hinting that we talked about in lesson 1. Let's check these asserts, and we have an assertion error. 1, 2, 3, 4. Failed on singular. Oh, that's right, because I have literally just talked about that. If, let's just go len mat equals 2. Honestly, we could make this more robust by making sure that that I and j are equal, that the matrix is square, and I encourage you at home to do that, but I'm just going to be a bit lazy here and just do it like this. So here I'm going to what's the word I'm looking for? And they're calling me. They really want to play video games with me tonight. Let's see. Len mat equals 2. If I remember correctly, A, B, C, D, A and D swap places and B and C swap signs. So that'll be mat 0. You know what? We're just gonna change the original mat. Mat 1. No, 0, 1. Mat 1, 0. And mat 1, 1 equals mat 0, 0 equals mat 1, 1. And then mat 0, 1 and mat 1, 0 just become the negative of that. Mat 0, 1. And then again, negative mat 1, 0. And then the last one is mat 0, 0. Right? Hope that's correct. I don't. How is this failing again? I'm a little confused here. Did I? No, we're still having this failure. Why are we having this failure? Let's do some live figuring this out, shall we? Let's see. A. I don't understand why it's saying this. Yeah, okay, so determinant is the issue. It's skipping over this. What is the length of this? Why is this? It's 2. So why is this not happening? I'm a little confused, to be honest. Oh, I know what the issue is. I'm a dumbass. Return mat. Honestly, in this particular case, because since here I'm actually manipulating the original matrix that's given back to me, even if I don't return it, the original matrix is changed. Um, so actually, I accomplished the tasks, but just making it consistent with the other return pathway. So it was easier to do it that way. Um, Ideally, you would want to do a copy like mat.copy, or like not just mat.copy, but mat.copy of the inner list as well, because from the bug we encountered yesterday, we know that when you copy a list, it's only copying the top layer list, not any other mutable data structures that are nested within it, which makes complete sense. So let's do this again. And do we have, oh, we do. 3x3 failed on the 3x3 example. It's supposedly from a common one. Determinant takes, oh, that's right. I need to do the determinant of the minor, so I have to do get minor. There you go. That should fix that. Okay, let's do this. All cofactor tests passed. Sweet. And that's the video for today. Thank you all for sticking around. Hope to see you guys again soon. Remember to stay curious. That's the most important thing. Peace out, guys.